Okay, so yesterday we finished 9.04. We started 9.05. Today we'll do the second half of 9.05, and we'll talk about Z-score. It's good to kind of be a little bit ahead. That way, I think by Monday we can finish all the new notes. Tuesday we can have as quiz review, and then Wednesday will be your check-in quiz. Okay, so let's go to page 20. And let's go to part, let's see, page 20. Sorry, page 19. I accidentally didn't put all the problems together, but the very bottom of page 19. So last spring, 250 students took the Algebra 2 final exam. The scores were distributed normally, so we know we can create our table with all the columns with a mean of 70 and a standard deviation of 5. Let's go ahead and put our normal curve on the next page so that we can refer to it more easily. So again, sorry, I meant to put all that on the top of the page. But again, the mean is 200. The mean is 70, and then standard deviation is 5. So 70 is the middle line, and then add and subtract 5. 3 standard deviations, the left is the right. Right now, I filled everything in with percentages. With this statistical probability, we just have to know we have to move our decimal back 2 places to the left. Okay, so hopefully everything feels straightforward. You can just go ahead and go down the line, see if you can answer those questions. Okay, so 15, we can just take that percentage, give it to a decimal, and then to a probability and multiply that by 250, right? So notice everything is up until 14 is percentages. Okay. If you're good with that, go ahead and finish do part C. If you're comfortable with that, we can start moving into the next section. Yeah, so for 17, 18, 19, create your normal curve. And then you're going to find the probability and multiply the probability by 1696. Okay, any questions, 17, 18, 19? So what we're going to talk about, I know we're working a little bit ahead, is, what if it's asking for a probability of something that doesn't land on one of the, doesn't land on one of the standard deviations? What if it's asking for, 9.2 or 10.5 or, 14? Anything that doesn't land, I mean, we can make an estimation, but we're not going to know the exact value because it doesn't land nicely on standard deviation. So today we're talking about z-score, which will allow us to figure out something that lands in between. It will allow us to find the probability for anything that lands on a standard or normal distribution curve. Okay, so page 21. So what do we do when the value that we're looking for, but that value does not fall on one of the standard deviations? Okay, so what we're going to do is we're going to create something called a standard normal distribution, which will allow us to use something called the z-score formula. So we're going to form this by using a mean of 0. So sorry that this got pushed down a little bit, but this is meaning to be a mean of 0 and a standard deviation of 1. Okay. So the empirical rule still applies to a standard normal distribution, meaning that, we still have the 34, 34, 13.5, 0.23, 2.35, and 0.015. So all that still applies. But we're going to change the x value from a normal distribution with a mean x bar and a standard deviation sigma to use a z-score formula, which is z equals x minus x bar divided by sigma. So x bar is still the mean. Sigma is still the standard deviation, but then x is going to be whatever x value that we're looking for at that moment in time. Right. The z-score is the number of standard deviation. The x value lies away from the mean. Okay. So for standard normal distribution, find the following probabilities of a randomly selected x value from the distribution. It may be helpful to draw a sketch. So your z-score of 0 will be here. A z-score of 1 just means one value away from the mean, 2 and 3. Okay. -1, -2, -3. So when you get a z-score, it's always going to be some value between -3 and 3, but we're gonna use a table that you're gonna see at the very front of the packet, and we're gonna use those. But right now, these are we have to understand that your z-score will always give you something that is to the left of whatever target you're looking for. So here, this is to the left of -1. Now we know what this decimal value is. We know that this is everything to the left of that 34 line. So it's going to be 13.5 plus 2.35 plus 0.15. So the probability of a z-score less than or equal to -1 is simply 16%. Okay. We're not going to be able to do it as easily as this later on because our z-score is going to land at a decimal value, and we're going to need some help to interpret that decimal value. But right now, the z is greater than or equal to 1. We know simply to the right of that first standard deviation line. So we know that's going to be everything to the right of 34%. So I can either add up all these decimals, or I can say 50 minus 34, because I know half is 50, which is also 16%. Okay. Between -2 and 3, so again, this is 0, -1, -2, -3, 1, 2, 3, between -2 and 3. So 13.5 plus 34 plus 34 plus 13.5 plus 2.35. Okay, so converting to a z-score.
So our goal is to get these numbers into something that lands between -3 and 3 so that we can more easily figure out what those values are. But even if it doesn't land at a nice whole number, we're going to be able to use the table that's located at the very front of your packet. Okay, so but let's first figure out how to do a z-score. So z-score formula is x minus x bar over. So the x is going to be the value that is presented in the problem. X bar will be given to you in the problem as well as the mean. Standard deviation is 3. So for A, if I want to find the z-score for 65, I'll say 65 minus 72 divided by 3. Let's practice getting all the z-scores down, and then I'll talk about how we can interpret this number with the table. Okay, 81. Make your calculator do the work for you. Okay, 76. All right, so we're going to use these numbers as we look at the example below. Okay, so we know what the z-score is, and then we're going to take this and apply it to the diagram that we see below for example 3. Okay. So now we're going to talk about, how can we use the z-score? So z-score enables us to find any probability within the table of values, even if it doesn't land on a nice standard deviation on our normal curve. The probability given in the z-score is a probability that is less than the z-score. So we have to understand that whatever the z-score table tells us, it's only going to give us what is to the left of it. And if we want to find out anything other than that, we got to involve 100%, or we have to basically make some adjustments. So the table is only going to give you what is less than the z-score. Okay. So be careful, because we're not always looking for less than. Right? We'll start off with less than, and then we have to make some adjustments for ones that are not less than. Okay, so for part A here, just so we can get some visual, let's just sketch the graph as far as, just in terms of what we can gather if it's 72 and standard deviation of 3, right? So I know 72 can go in the middle, 75, 78, 81, 69, 66, 63. Now notice that 65 is not nice and clean. 65 is somewhere here, right? But we have an idea of what it's going to be, right? It's going to be somewhere in that 2.35, less than 2 point, in that 2.35, 0.15 range, right? It's going to be very, very small, less than 65. But with the z-score, we can find out the exact probability. Okay. And the nice thing is that whatever we get from a z-score table is going to match what we're looking for, because this is also asking for less than. Okay. So we know the z-score for 65 is -2.33. I can carry that down. We already did the work for that. Okay, so now I want us to go to the very front of your packet. And we're going to look for -2.33 in the tables here. Now notice on the third page, everything is positive, my z-score, I want negative z-score. So that's going to be on the second page, right? So I'm looking for negative 2.33. I see negative 2.3, but I need a 0.3 from the 10th 100th spot. So this is negative 2.30, negative 2.31, negative 2.32, negative 2.33. Okay. You guys see how to read that table here? Okay, so 0.0099. Now, whatever they tell you is always going to be the probability. Okay, so the probability is 0.0099. Go back to page 21. So that's my probability. My probability for x is less than or equal to 65 is 0.0099. Now, if it's asking for a percentage, then you can say 0.99%. But that kind of makes sense, right? We're looking to the left of that 2.35%, so it makes sense that it's going to be in, that 1% range, right? Okay. Question so far? Okay, so for part B, probability of x is greater than or equal to 81. Again, I want to just have something to, so that for now we can kind of have some understanding as to what it's giving us. So greater than or equal to 81, we know that's going to be a very, very small percentage, right? Because it's going to be to the right of that 81. But your z-score is not going to give this part. It's going to give us what? It's going to give us everything to the left. So whatever, so if what you're getting is not what you're looking for, you can always subtract this number from what? From 1. Okay, because probability is 1. So if you're given a 1 side, then subtract from 1 and you would be good to get the other side. Okay, so let's go to our z-score here. Our z-score is 3. Okay, we go to our table. .00 is 0.9987. So it's giving us everything to the left of that 81. Oh, you're right. 0.81. Let me see. 0.987. Yeah, the z-score says 0.0013. But what we're getting is, if it was looking at a table, then we would be looking at 0.15. So it's a little bit off. But we just have to, I'll make it clear where I'm going to ask you to do z-score and when it'll just be a normal distribution. Okay, so in this case, we'll just follow the fact that they want us to use z-score. 0.9987, that's everything to the left of what I'm looking for. So if I want to do to the right of my z-score, my z-score table, then I got to do 1 minus 0.9987. Okay, so 0.0013 is a probability, and then the percentage is 0.13%. So this is where it gets a little bit complicated, is what happens if you're dealing with two z-scores here, okay? Less than or equal to 76, or between 76 and 81. Okay. So we have to understand that we're going to be looking for a z-score table for both 76 and 81, but 76, okay, let me, again, show the information here, 72, 75, 78, 81. So 76 is going to give us everything to the left of that line, right? And 81 is going to give us everything to the left of that line. So what's going to happen is, how do we resolve the two z-scores that we get? So anytime you're looking for something between two z-scores, you can just subtract those values. If you subtract those values, you'll be able to get that range that they're looking for, that you're looking for between your z-scores. Okay. So the z-score for 76 is 1.33. But sorry, let's find each of the probabilities first, okay, and then we can subtract it. So we don't want to subtract the z-score. We'll subtract the probability. Okay, so for 76 is 1.33. So 1.33 is on page 3, which is 0.9082. And you're always going to do the larger minus the smaller, okay? And then 81 is 0.9987, right? We found that from before. Subtract those two. Okay, so are we clear on all the three different variations that you get? So if it's less than, then z-score, whatever you get from the table is what you're going to put down. If it's greater than, you have to do 1 minus the z-score to get you to the true probability that you're looking for. If you're looking what's between, find the two probabilities first, subtract them from each other. That will be what's between your two values. Okay, let's do a little bit more. Let's just do number 1. Okay, page 22, number 1. Okay, I'll do it alongside you guys as you guys try it. Part A, you see less than or equal to, so you know this will be easier. Whatever you get from the z-score table is going to be your answer. Negative 0.5, 0.3085. Greater than or equal to 47, you're still going to find your z-score, you're still going to use the table, but we got to do 1 minus the probability. It's always asking for a probability. So it's always gonna be whatever the, whatever the table gives you, you keep it in that form. And part C is, these are the most complicated types where you have to find the z-scores for both, find the probabilities for both, and then subtract the two probabilities. The larger minus the smaller.
So I accidentally didn't turn my 2.3 negative and made it positive, and I found like the whatever thing, and it ended up being 0.9893. Is that fine if I don't make it negative and I just make it the absolute value and I find the positive so I can find it? Does that work every time, or is it?
It should. Um, so let me know if something doesn't quite fit, but it seems like it could work.
Okay.
Yeah. So if you do it that way and it doesn't match my answer, let me know and we can discuss further. So if you're comfortable with this, then that's good, because really on Monday, we're just gonna be practicing more with this. And then Tuesday review, so at least we've kind of seen everything that we need to see, and there's no more new material that we won't see new material until after the quiz. But I wanted to get this in early so we can have some time to make sure we are comfortable with it.
Checking if it's gonna have a calculator.
I think it's just gonna be calculator, just
Maybe
calculator.
at the table.
Yeah, the table as well, right? Okay, so part D, you can just keep whatever the z-score table tells you. Part E, subtract from 1. Part F, subtract your two probabilities. Make sure that you don't subtract the z-score. That you find the probability first and then you subtract the probabilities.
I didn't know if you could like subtract the probability from one.
So when you're looking at your two probabilities, there's always gonna be one that's larger. So just do larger minus the smaller. So if you get a negative number, you know you did the opposite direction. So to make it positive. Yeah. Okay, you got a minute to finish up to F. And then at least we know that we've seen everything new. We can basically finish up on Monday. Finish and then do the next section, but the next section is really just applications of the same thing. Nothing really new. Okay, once you guys are finished, come get your phones.
So when we take these values, it's always from the zero columns.
If if it's negative 2 if it's just one, this is a 10, like, if it was like, if Z score is like negative 2.53, then I have to go to this column. That makes sense. So, for instance,
Oh, that's for the hundredth place?
that's 100th place, that's right, that's right. If it's the 10th place, then you can just look at that.
Okay, and then also, so for when it's in between, do you do the larger minus the smaller one, or is it?
Always larger minus small. Okay.
Open